Okay, today's video is discussing this concept of arc length. So we talked about in 5.1 arc measure. So don't you love math? Yay, yay, yay. Where the length of something is not necessarily the measure of something. Okay. The length of the arc is the length of what I would call the crust. Okay. I made that kind of analogy. It's the length of the crust. So if I were to walk from point A right here to point B right here, what would be my distance that I traveled? The arc measure is really referring to the central angle and the measure of the angle that it's creating. So while those words are very similar, they do in fact mean different things. So I'm just going to give you the formula and then we're going to plug and chug some of this stuff, okay? So what this is talking about is it's a portion of the whole circle. So when I tell you that this formula kind of looks a little freaky, it's because it is taking a portion of the circle, multiplying it by a formula that we already know. Okay. So what you're going to do is you're going to take the measure, and we'll just call it this measure of the angle. We'll call it measure angle A. Okay. But it's the measure of the central angle. Okay. So the measure of angle A, meaning the measure of the central angle, over 360, because 360 is the entire circle. Okay. And because we want to know the length of that portion, what is the length of the entire circle? The circumference. Okay. So if I wanted to know, if I cut a circle and laid it out flat, the measure of that would be 2 pi r. Okay, that's the circumference formula. So 2 pi r. R in this case being the radius, pi being 3.14. Okay, now you can use the pi button on Desmos. You can use the pi button on your calculator. Don't really care, doesn't matter. This is asking for nearest hundreds. I will also tell you that sometimes questions ask for the answer in terms of pi. Okay, what does that mean? It means plug everything in except for pi. So you're going to get like everything but pi. And I'll show you what that looks like in all of these examples or a couple of the examples until you kind of get it. Okay. But in terms of pi means you're going to plug in all of the numbers, multiply everything, and then tag pi onto the end of the answer. Okay. So here we go. We want to find the length of this bolded portion of the circle. And that's how that's how Delta Math will give it to you. They will either bold it or they will give you the arc measure. Okay. They might label it, AB and ask you to find the length of that bolded portion. Okay. So it's the central angle over 360. It's that portion times 2 pi times 6, because 6 is our radius. Okay, so in my handy dandy or in Desmos, whichever one your heart desires, we got 107 divided by 360. Then I need to move my right arrow button to, hopefully you see pi. I don't know if you can actually see my computer screen because, like, can this thing go away? Oh my gosh, I've never done that before. What the heck? Okay, I want to make, no, I don't want to do that. I just want to move the whole shebangy bang. Can you guys see that? What is happening? No, I don't want to do that. Can you guys see that? Okay, never mind. I was the little icon bar. Anyway, wow. Okay, this little pi button right here. If you can see my little cursor right there. Okay. Woo. right there, pi. So use that button. Oh, cool. Pi. Pi. I don't even know what I was just doing right there. Okay, times 6. Okay, now you can definitely do like times pi times 6. You can separate everything out, or you can write it individually. So in terms of the hundredths, we would go 11.21. Okay, that is to the nearest hundredth. And I want to show you what it looks like in terms of pi. So if you write your answer in terms of pi, what you're going to do is you're going to type everything in but pi. So you're going to get the 107 divided by 360 times 2 times 6. And then you can change that to a fraction if you want to. Ugh, gross. But I would probably just do 3.57 pi, honestly. 3.57 pi. So you do everything but the pi. So hundredths or in terms of pi. So this is in terms of pi, depending on what Delta Math is asking you. Okay, cool. Next problem. The central angle, so 38 of the circle times 2 pi r. And in this case, it is 15. So here we go. Type it in your handy dandy. Pi on your handy dandy. I'm gonna have to pull up a calculator. I mean, you guys probably already know. ATI 84. I just feel like I should have it memorized. Like I should have it memorized. I just really need to go to the images. Second, why is this? Bless. I'm really wasting time on this video now, aren't I? I really just want a picture. Where the can I go in there? Oh, second, and then the little caret button. Okay, it's right under clear. There it is. There's pi. Sorry. Bless it. Bless it, Lord. Here we go. All right, 38 divided by 360. Right arrow, 2 pi times 15. So 9.95. 9.95. I do not care about inches or centimeters or yards or miles or whatever meters it's talking about. Okay. And then if you do it in terms of pi, it would be 3.17. 3.17. And then you got to put pi onto the end of it. Because again, it's doing everything but pi. Cool. Awesome. All right. Cool. I feel like you could do 3 and 4 fine. Let's move on to number 5. This says if EB, so if EB right here is 15 centimeters, we want to find the length. There's the big difference, not the measure, the length of CD. So if I wanted the measure of CD, I would find the angle, which we still do have to find the angle measure, okay? Because we need that in order to find its arc length. Okay, so the measure of the arc is that portion of the circle times 2 pi r. Now, in this case, r is 15 again. Now we need to find the portion of the angle. Okay, we know that this whole thing from B to D is 180. Ooh, that really sounds southern. Okay, 180. I'm going to minus the 68 off of it and find 112. So the 112 degrees is the measure of that central angle. So I need the measure of the central angle in order to find the length of the arc. A lot of words. A lot of words. Okay, cool. Here we go. 112 divided by 360. And then times 2 pi r. So 29.32. Make sense? All right, I'll show it to you without in terms of pi. So times 15. So 9.3 repeating. 9.3 repeating pi. Weird, but whatever. All right. Cool. I gotta give you a word problem. Word problem. The party's just begun. There's a word for everything. Word party. Anyway. You may know what a pendulum swing is. A pendulum swing. It's like, think grandfather clock. Shwibbity, 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 schwa. Okay? So I've got a 16-inch pendulum swing, or 16-inch pendulum, okay, swings through an angle of 40 degrees. So let me just make this very clear for you. Okay? I've got a pendulum. We'll call it kind of that. It's swinging at an angle of 40. So it swung. It went that direction. Okay? Think of it like this. Ooh, like a little girl. Okay? Maybe it's better like this. Okay? It's a little pendulum. Little pendulum like that. That's what we're looking at. So if I'm down here at the 12 o'clock and I pendulum swing, then I'm going, there you go, kind of like a golf club. Pendulum swing. When you go put in the next time, or pendulum swinging. Hope I've ruined everything for you. Okay? So of a 40-degree angle. So here is my 40-degree angle. How far does the tip of the pendulum travel in the swing? So we want to know, here's the tip of my pendulum. We want to know this. What's the distance that I've traveled in that swing? Okay. So the portion of the circle, 2 pi r. Well, some of you are like, oh God, what's r? 16. It told us that. A 16-inch pendulum. There we go. There we go. Words, words fail, words fail. Okay, there we go. 11.17. 11.17. I'm not going to write that in terms of pi. You guys get it. If it comes up on Delta Math, there it is. Okay? Woohoo! Roundabout. Lord have mercy, people don't know how to drive in a roundabout. You know a roundabout? You know a roundabout? The roundabout that really makes me mad is the one at the fountain near the YMCA. That one really ticks me off. Okay. The one like it's right there at the YMCA. It's got the little fountain. It's over on Morrison Plantation. That one makes me angry. The other one that kind of freaks me out that I don't like to drive in is the one in the Trump area. Okay, right near the clubhouse. I do not like that one because I just feel like people are just zooming and I do not like it. Okay. But a roundabout. Okay. Let's draw a picture. Okay. You got usually a center point, and then you got this kind of this little thing, okay? But let's say we enter here at Morrison Plantation and we go over to here because that's where like the Harris Teeter and the Brooklyn Brothers Pizza, Tacos for Life, all that, okay? And then if I keep going, I can go and get off on the exit where people also don't know how to drive, which is near that Lowe's Food, kind of the top entrance of that Morrison Plantation entrance that's right off of, why do I feel like I don't know what that road is? You know, the one with the post office and all that. Okay. And then it kind of, I think there's only 3 exits on that one that's with the fountains. Okay. So here we go. It says a car entered a roundabout from Mason Avenue. So let's call this Mason Ave. Okay. It traveled 280 feet. So let's call this 280 feet because that feels like a lot. I'm going to go all the way to this exit. Okay. So this is 280 feet. Turning onto Perry Street. If the roundabout has a diameter of 150 feet, so okay, fun fact, there we go, 100 150. Oh, Lord, 150 feet. Okay. Find the angle of rotation from Mason Ave to Perry Street. So what I want to do is I want to find this angle that I have gone. Cool. I love that. Which means that I don't know a really key part of my problem. I do not know the portion of the angle. Okay? I do not know the portion of the angle. So times 2 pi, and then r would be 75 because my diameter is 150. Just cut it in half. Okay? Now, that is equal to, I can only have one unknown. I can only have one unknown because if I have two unknowns, then what the freak am I solving for? Okay? Okay? My other piece of information is this 280. That is the length of the arc. So that's what my answer is equal to. That's all the things that I've already found. Like all the problems that I've done so far, I've been finding this 280 value. Now I am finding the angle at which I'm going. So now I have to solve. So a couple of different options here. Okay, you could absolutely multiply both sides by 360 first. Gets rid of your denominator, makes it really nice. Let's get rid of that thing first. So I'm going to multiply by 360 on both sides. That gets rid of my denominator, and I hate fractions. I mean, I don't, but I know y'all do. So there's that. Now, this is an astronomically large value. Okay. There's that. 100,800. I think that's how you say that. Equals x times 2 pi times 75. Now, if you will please pay attention, you absolutely could divide everything by 2 pi times 75. It's all multiplied. So it's not like I'm adding, subtracting, whatever. I can divide the whole thing by 2 pi 75. You just have to put it in parentheses in order for the calculator to process that. Okay? So here we go. Divided by 2 pi times 75. So 213.9. The directions, if we go back and read, ask us to round to the nearest degree. So 214. And I love this question because it actually makes you have to use your little noggin. Okay? Perfect. All right. All right. All of that is still arc length. So you could go in and you could practice a gajillion million more of those. You would solve for different pieces of the puzzle. So I'm going to pick, probably should pick 12. Number 12. Now, theta, we haven't maybe seen. Theta is an unknown angle. Okay. The unknown angle is what I'm going to be solving for. We kind of sort of just did that. I'm giving you the arc length of 12.22. I'm giving you the radius of 5, and we want to find the angle measure. So what portion of the circle times 2 pi r equals 12.22? That would be your setup. What portion of the angle, because I don't know. I don't know. The angle is unknown. Over 360 times 2 pi r equals the 12.22. That's the measure of the length. That's this portion right here if I were to walk from X to Y. The crust. How much crust are you eating? Okay. My children eat 0. So there you go. All right. I'm going to get rid of the denominator. Makes my number really big, but it's not bad. Okay. So anyway, X times 2 pi times 5 equals 4399.2. Perfect. And then all I have to do now is divide by 2 pi 5. Or you could do 10 pi. Who cares? Right? However you want to do it. But I'm going to put it in parentheses because I want my calculator to just do that. So 4, 3. Divided by 2 pi times 5. And before y'all come at me with your information, okay, hold on. 140. If you are in Desmos, I do believe you do not need your parentheses if you set the fraction up. So before you come at me, I don't need the parentheses. Yeah, I know. I got you. But listen, I would rather do more than less. And I know that I'm going to get the right answer. Okay. Okay. All right. What else can we solve for? The circle, we found that. Oh, yeah, we probably should do this one. Number 13. A circle has an arc whose measure is 80 degrees. All right, so you draw yourself a little circle. What you know is that the measure of the angle is 80. And the length of its arc is 88 pi. Now that's lovely. They've written it in terms of pi. I love that. Okay, we want to know what the diameter is. You might be asked what the radius is. This is the same process if you have to find the radius or the diameter. Our problem, our formula is in terms of radius, right? That's what's in the formula. So we're going to have to find the radius anyway, and then just multiply it by 2 to find the diameter. All right. So portion of the angle, 80 over 360 times 2 pi times, I don't know, 2 power equals 88 pi. Lovely. Still going to multiply by 360 on both sides. Still going to look nasty before it's going to look better because I don't know about you, but 360 times 88 pi. Okay, yeah. I'm actually going to do this. I think I might just do that. I guess I could do that. That looks disgusting. Whatever. 99,525. 99,525 point something 65. We'll go 66 equals. Okay, that got rid of that. That got rid of that. Careful. You're left with 80 times 2 pi r. Okay, so here we go. We are going to divide by 80 times 2 pi because the unknown here is r. 80 times 2 pi. Be careful. Okay, here, I feel like I want that to go here. Can I copy that? How can I make that? I wonder if I could do like A and S, like in my calculator. No, I cannot. 88 pi. I have it like there's a way I can do it, but whatever. So 99,525, 6. We'll go 66. That's fine. Divided by 80 times 2 pi. 198. 198. All right, cool. So that is equal to, oh, I think my pen died. Oh, Lord. Oh, no, it's dead. Okay, so let me walk you through the rest of this. So we got 198. That was my radius. 198 was my radius. My radius times 2 is the diameter. So my diameter is 396. And that, my friends, is all we can accomplish in this video because now stuff is dead. Okay? That's it. Love you. Bye.